So yes, thanks everybody for being here. This is another session of the digital approaches. CEFISES Seminar, I could, I was about to say, I could try to take some kind of credit, be like, look, we brought somebody all the way from Canada. But at this point, Kevin's been here so long, he's like, I feel like you practically count as a local if you've presented a project to the Bureau of the Institute at this point, which, I mean, like, you did. So, an honorary CEFISES member at this point, with good luck with postdoctoral fellowships, maybe an actual CEFISES member before too long. But without further ado, I'm excited because we've worked together on other projects, but I still haven't really heard what his actual doctoral thesis is about. So he's here to present his doctoral thesis research, which involves, among other things, empirical approaches to understanding interdisciplinarity, which is a thing that lots of people here are interested in. So yeah, take it away.
Yeah, thank you, Charles, for the presentation. So basically, it's a meeting between me and Charles. We just have never the time to meet. So you're invited, though, so you can comment. It's quite nice. So some of the stuff that I will present today, most of the stuff are quite new for the empirical result, because for my thesis, at least at its state of progress, I wasn't really there, so it's fresh out of the oven from yesterday. So hopefully there's not that many, how could I say, like, small error here and then, but the general idea here is to present you my continuous nightmare for the 5 last year. Yeah, thank you so much to welcome me to talk about that today. So we'll talk about interdisciplinary research. So just to be forward with that, so when I started to work on that project, it wasn't up for the money. It was basically because I found that the use of the term was a little bit too widely used and applied and reused and served to validate certain discourse that are not all great for research. So the main, if you want, the main intuition or the main instead there was purely like to do some cleanup in that particular field. I was happy to see that people work on that and do really serious work, but keep in mind that people working on how do we conceptualize and measure interdisciplinarity, it's still messy. It's an ongoing topic of study. So anyway, so let's go with a little bit of background. So why do we care about interdisciplinary research? So some people care externally and internally to science. Externally, you probably know what they have in mind. Internally, there's some epistemic virtue that would be instantiated by that particular kind of research. It's not really clear what people have in mind there. So usually they tend to distinguish monodisciplinary research from interdisciplinary research. We'll see later what that means. But usually the kind of advantage that would be that would emerge from those kind of practices are usually linked to some instrumental capacity, in the sense that it would be more able to solve social, economic, and environmental problems. Also, some people defend that it will increase research quality, promote innovation, and that's quite new. I saw that a couple of years ago at a Congress for FRQ, it's a fund in Quebec to fund research. Like people claim that interdisciplinary research would help us to challenge monopoly, like English as the franca lingua in science, and also help us to work more on local objective studies, even if what's at least good strategy for now as a researcher is to work on universal subject of study. So that's the base. In philosophy of science, it's quite new as a subject in itself, but it's a new old subject in a sense, because you have all the Vienna Circle, for example, that work on that starting the 1930 at least. Also, the problem of specialization in science. Auguste Comte was already talking about that before, but there's even earlier researcher there that were talking about those particular issues. In philosophy of biology, where I come from, it's really well documented, at least from the 80s. How do we conceptualize interaction between science that is not reductionist? But as a full-fledged subfield in philosophy of science, we have to wait until the Schmidt paper. At least that's the first occurrence of the term philosophy of interdisciplinarity. From that Schmidt paper from 2008. So it's quite new in a sense, and the agenda also it's quite new. So if you're interested to know what people are trying to do in that particular field, look at Mackey 2016 paper, really nice for that to set an agenda. Hey Daniel. So quite new in the philosophy of science, but there's already been work on that particular topic. So what is interdisciplinarity research in a nutshell? So classical distinction is that one. So there's multiple ways to classify those particular approach. Usually, as people that study those kind of phenomena, we tend to focus on those three because people tend to invent new concepts every year or just try to reduce them. So we try to stabilize the concept just to keep the work being translatable. But yeah, usually when we talk about multidisciplinarity, we talk about juxtaposition of multiple disciplines. So we just cross the look on a particular problem. So for example, a multidisciplinary book would be like, what is the concept of woman? And then you look at that concept from a biology perspective, psychological perspective, a feminist perspective. So that would be multidisciplinary. Interdisciplinarity come with a particular notion, or at least it's usually framed that way. So it needs to be more than just juxtaposition, even if there's benefit to juxtaposition. It always, or at least some people defend that it needs integration between field of science, meaning we need to bring together elements from different disciplines and try to do something meaningful with it, whatever that means. Transdisciplinarity, multiple exceptions of that, but usually people tend to frame it more like it's like interdisciplinary research, but with more instrumental focus, if you want, with extra academic consideration. So baselines there. So what about my research project then? So as a naive philosopher, I was like, so how do we study interdisciplinarity and measure that particular kind of thing? Because it's a weird phenomenon in the sense that some people don't believe that interdisciplinary is something in itself that has particular feature that we can study as a whole. Some people defend that there's just multiple versions of it. Some people defend that it doesn't exist. But my general question was so how do we look at that particular phenomenon in science? Because it's there, it's widely used, at least in the discourse, so there's interest as a philosopher of science to look at that. And more specifically, so considering the kind of tool that are present in front of ourselves, so meaning a tool as we could be theoretical tool or methodological tool, how can we supplement, if you want, the toolbox that's already present there? Because the idea with a thesis is to contribute in some way to the debate, and I found that particular way was the most relevant for considering the state of the field. So multiple aim, try to map what is the toolbox actually offered, propose a tool, and ensure that tool is not that bad, so it's relevant in a certain sense. So general argument, just so you know where I'm trying to go with that. So one problem that the toolbox actually present is there's a lot of development in what is interdisciplinarity as a concept or as a particular practices in science from a theoretical perspective. And there's also a lot of work on how do we measure that particular kind of thing, especially from scientometric or bibliometrics, but they tend to fall either in those two categories in a sense that either it's really theoretical in the sense that it's not applicable to a lot of cases or new cases, or it's so applicable that the theory behind it's not helping us in doing some work. I will give you some example later. So general argument is to say so current offer fall into those two categories. What would be nice is a tool that at least go more to the center, not to say that it will surpass one side or the other, or the tool in one side or the other, but just to say maybe we can have diversity in the kind of tool that we have to not be stuck in those two extrema. So my hunch, if I can call it that way, is that since we have a lot of discussion about what is the relationship between field and science, what we call unity of science, that's a nice repository of tool that we can try to implement to to bring new tool to the particular toolbox. So my hunch is to use that particular corpora to work, and then to do some tests to see like, is it theoretically potent in a sense that it helps us to see, okay, so when we observe something, was it supposed to behave that way or not? We'll see later again what was the problem there, but also are we able to implement it in a way where you can apply it to multiple cases without knowing too much about that particular cases. Just to help us not to do only close reading stuff, but to be more systematical in our way to analyze that thing. So let's look at the current offer. So I try to use that particular fiction to communicate what I have in mind, because since I'm in how could I say, in an environment with a lot of sociologists of science, historians of science, sometimes the epistemic dimension is put on the side, saying like, well, I mean, it's all social power, so epistemic dimension doesn't have, it's not a relevant level of analysis. So that particular fiction usually aim at framing the problem in a way that it's relevant for us to think about the epistemic dimension of interdisciplinarity. So imagine that particular researcher, no strong disciplinary conditioning, in the sense that the kind of tool that she has doesn't condition too much the way that she analyzes a particular problem, and also imagine that she doesn't have too much, at least production constraint, in the sense that she doesn't have to publish only sociological work or history of science work. She's flexible. So the general idea, the egothematic environment, in the sense that the kind of questioning environment that we have, at least if we frame it that way. So what kind of tool that we have in front of us, what are the costs and benefit of those particular tools, and what are the kind of questions that we can tackle with those particular tools. So that's a communicative tool just there that I presented to you. But yeah, so keep that in mind. So as I mentioned, two subfields work a lot on the particular topic of interdisciplinary research, interdisciplinary studies. Those two fields, I would say, are the most sophisticated on the kind of theory or tool that they provide. There's some other stuff, like in literature, for example, but the wide, since it's a super wide subject, like every field has its own way to tackle that subject, I would say, or I will defend that those two particular provide the most sophisticated tool that are there. So by theory of interdisciplinarity, what I have in mind, it's the subfield that it's called interdisciplinary studies. Probably you've seen that before or not, but the idea is to try to understand interdisciplinarity, what it does, what it brings, compared to monodisciplinary science. It's a kind of old field in the sense that it was framed that way in the 90s, so there's a lot of literature on that particular from that particular field of science. In bibliometric, just there. It's also it's a new, since it's a new field, it's not been a long time they've been working on that particular topic, but as soon as it rise in 2008 or something like this, where common tools were designed to measure that particular dimension, now it's standard way to analyze science, as they use always gender analysis, because we always find nice difference to see there. Interdisciplinarity, it's also one of those classical dimensions in bibliometrics that we use. So if we go a bit there, so in theory of interdisciplinarity, you have multiple accounts. You have the generalist family of account that say like, well, interdisciplinarity doesn't need integration, it could be whatever, so I don't know that much about their work. The most sophisticated proposition are mostly in the family that we call the integrationist account. Those are three different accounts where people go back and forth to say that their account is better. So you have the algorithmic one, it's a quite old one, it was proposed initially by Julie Thompson-Klein in the 90s, and it was reprised by Repko and Svostak, notably through their textbook that teach us how to do interdisciplinary research. And I cannot tell you how much I would like to aid that book or see that book. It's bad, but it's super great work, sadly. So yeah, and I talk a lot with Rick Svostak. He's a really nice guy, but he really the way that they work their particular tool or the textbook that they produce, it's 20 years of work with sociological survey of how students learn, and so it's really neat work on that. But technically, yeah, so you have a sequence. If you follow that particular sequence, then you end up with interdisciplinarity, just to put it bluntly. The sociolinguistic account, it's Julie Thompson-Klein that was dissatisfied with her homework, and after reading Habermas, she go full-on communication mode. So it's a less, so she keep the iterative process, if you want, of following a certain series of steps to produce something, but she's way more skeptical in that particular account on how those steps should be structured and what do we keep at the end. For the IPO account, so input, process, output, it's quite new. O'Rourke and Goderman, I think, and Crowley proposed it in 2016. Super nice work. They took back the algorithmic account work and also include into that all the discussion that were made about integration in philosophy of biology. So they really have a nice account. I don't remember if I can talk. Yeah, we'll see later what it looked like. See the time that goes. Maybe I'll go. So those two I already mentioned briefly, but maybe I'll stay on that one. So, so the general idea there is to, but at least for O'Rourke, Goderman, and Crowley, for them the particularity of integrative or interdisciplinary integration is the fact that it's a particular progress where we have different input initially, and at the end we have less input, less output, but that are qualitatively different. So they really put forward the study of that particular process, put it even more forward than the other account would do. It's in a certain way more formalized also because they search to propose a general account of integration, but it's constructed in a way that we don't follow a particular sort of step, so they don't follow the algorithmic account with that, and it's simply they frame the problem as what produce interdisciplinary research. It's really different, different stuff that were initially put into the process. Anyway, it wasn't the right way to produce it. Let's use that nice table instead. So you can separate those different accounts on different dimensions. So how they characterize the process, the element that are bring together, the product of that particular process, and what the kind of question that they want to tackle. For most of them, process look like. They tend to disagree on the kind of question, especially. So for the algorithmic account, they say like, yeah, there's a certain set of problems that interdisciplinary research try to tackle. Those are specifically complex problems. For Julie Thompson-Klein, it's not the case. It could be whatever empirically is measured as interdisciplinarity. So she's way more skeptical about that. And and that's the point I wanted to say with that particular table. For O'Rourke, they even remove the need for a particular problem where people tend to agree and then try to solve together. So it could be an aggregate of problem in the sense that if or interests converge, it could be also interdisciplinary work. Yeah, so basically it gives you an overview of the kind of tools that are available there. So I think I won't go too far on those things, but for the kind of tools that are available in bibliometrics, they tend to differentiate by the kind of approach that they have. So most of them will use top-down approach in the sense that they will use metadata about per paper in science and use those particular things to try to see, okay, so that particular paper, since it's cite discipline that are, how could I say, like less often used in producing that particular paper, then we can qualify it in a certain way as more or less interdisciplinary. So in that particular account, they use classification that come with a journal, for example, or manually set classification to do those particular analysis. So they use basically reference section. In every paper in the reference section, they just qualify which discipline and then compute the some sort of diversity index to choose. Is it more or less interdisciplinary? For the bottom-up approach, quite different kind of tool. They tend to try to use, how could I say, like the structural property of the data set to see, okay, what is a discipline there and what is collaborating. So they use typically a citation network. For now, the work on that particular field are not going super well, but the idea is to say, like, instead of allocating a priori what is a particular discipline or a field, they try to reconstruct it through how papers cite each together and to group community that way. They also use another kind of tool that people use in that particular field is to, in that particular approach, is to use textual similarity between papers, saying like if it's way more different, those things are different. But if you bring language that seems like one discipline or another one, then you could consider it as more interdisciplinary. Hybrid just mix those things up, so I will pass super fast there because I talk about that later. Multiple kind of tool that already exists for that. The most used and the most standardized is the Raoult Sterling. We'll see that later because I use it for my particular case study. But there's a lot of development in that particular field, but they have at least one typical tool that they use for that particular measure. Okay, so the particular the limit of the current offer. So as I mentioned earlier, at least in the current offer, there's two extrema. One is we have high theoretical patency in the sense that we know what we're searching for, we know how it should behave, and then if it don't behave as it should, then we either have problem with our theory or we know that it's not what we're looking for, or you have that other extrema where you have those really nice tools that compute easily degree of interdisciplinarity, for example, but when they face problem, contradicting case, for example, they don't know how to solve those particular problems. So, for example, on the full list of tools that I showed you before, mainly the debates tend to focus on which tool have the better formal property. So we don't have a poster child of interdisciplinarity, so we don't know how to calibrate our tool or to be sure that we measure what we are measuring. So there's a lot of debate about, okay, if my tool satisfies more particular property, then it should be better in absolute. So they don't have a lot of theoretical background in a certain sense to rule out which tool is the right one. They have to rely on general characteristic. So for me, that's a big problem, and that's why, as I mentioned, I wanted to try to produce something in between. That being said, we'll look a little bit at the proposition that I have in mind, especially if there's philosopher here, philosopher of science. That would be, I think, of interest for you. At least I would be interested to get your advice on that. So, general idea, as I mentioned, 100 years of work on particular how field of science interact together. Is it reductive? Do they just collaborate or exchange stuff? What do they exchange? Data, method, or a concept? But I think that the particular phenomena that's called interdisciplinarity could be framed as a form of unity of science. And you'll find that on the cat entry on the Stanford Encyclopedia of Science, Philosophy. Sorry. So technically, if you compare it to other kind of unity, it would be more local in a sense that would imply not the whole scale of science, but only a couple of fields of science. It will be also epistemic in the sense that it's quite rare that practitioners try to defend that, we should do interdisciplinarity because we live in one world. So that's not the kind of talk that they use. Usually is to say, okay, so we need tool or we need way to solve problem, and by mixing up approach or at least capacity from different fields, we have better way to solve a particular problem. And also, like it would be considered non-reductionist in the sense that rarely they would say, like, my field, we use that particular field because it's more general than the other one, and since we can deduce the field B from field A, then that's the right relationship that we need. So they tend to say, like, to defend some sort of epistemic pluralism, in the sense that they respect the authority of the different field of science, and they think that all those fields have something to bring in a particular question. Okay, so the answer I have was based on the particular separation in what could be called conception of unity of science. So unity of science, it's a conjunction of two theses: unity in science and unification in science. So the first one refer to some sort of commonality in science. It could be language, it could be laws, it could be whatever, but some sort of unity. And unification, that we don't see there, refer more to the process that produced that particular unity. So that separation is not usual in recent talk about how fields go together, but it's a really nice analytical distinction, especially in bibliometric. They tend to go that way now, to separate the process from the product. So that's the particular intuition I built on. Maybe I won't go too much into those. Yeah. So just to give you an idea how, like, once we have those two dimensions, how different propositions fall on. You can think about the movement for unity of science, from Carnap and Neurath especially, as defining unity in science as a linguistic unity. So phenomenalism at first, and then physicalism after Neurath did his work. They also believe that the relationship between the different fields, what produce unity, is actually a reductionist relationship between different concepts, or a reduction between concepts. So you can frame it in that at that particular place, but for more recent account, and I think I won't go too long on that, you can think about the neo-mechanistic account, or the new the Stanford School that was well known for reviving the mechanistic language in philosophy of biology. So for them, depending on with whom you talk, usually they say, like, well, the field. Every field has something to bring, at least when we study phenomena that have multi-level functioning, and the right language to talk of those different levels of reality is the language of mechanism. So they tend to support the unity of language thesis there, but it's more local if you compare it to the movement of unity of science, because they don't think that it should be applied to all the science. For them, it's mainly psychology, certain sector of biochemistry, and even they took evolutionary theory there. But just to put, what I want to put forward there is, like, once you grasp that particular separation between unity in science and unification in science, you have a nice tool to separate which account try to do what, and the kind of limit that they have. So for me, at least, based on the work that I did and the status of the general debate about disunity of science, I mostly go into the linguistic account and the connectionist one. So linguistic account saying, like, okay, so we have multiple accounts that say, like, well, a general language seems to be needed to help field to work together. It could be a mechanism, but it could also be a complex system language or system language, depending how you want to frame it. So it seems that we have multiple local general language that seems to do that particular work. But at least for the recent discussion about how relationship between field work, there seems to be some sort of consensus where the right relationship is not to be defined a priori, but it's case-based. So it could be reduction sometime, it could be integration sometime, but there's no clear cut saying, like, oh, it's always by reduction or always by integration, because there's always cases that we find that are marginal but problematic, even in biology, where most of the cases you'd say, like, those are integrative relationship, but some fall under the reductive conception of relationship between field of science. Yeah, so that's what I wanted to say there. So what I mentioned is exactly that. So the idea is to say that there's no one general language that can help unity of science, and the right relationship between the field to solve a particular problem or whatever you want to, how you want to frame it is based on what we try to do. So it could be reduction, it could be integration, but I think we can frame or at least understand interdisciplinarity if you took the 3 points that I mentioned before in that as a special case of that where the problem are local. Usually we use integration, but it could be something else, and we try to fix a particular kind of problem with those approach. So in a nutshell, you saw my what I tried to work on. So as I mentioned earlier in the general agreement, at least for me, if you propose a tool, you have to look if that tool satisfies certain criteria. So is it useful at least a priori? Before you put the work into trying to operationalize it, like you should look at some basic feature. And after that, even if your proposition has those particular feature, if you don't have empirical data, it's difficult to just propose something in the wild like this and don't show how empirically it can show relevant, or at least show us relevant insight about the phenomena that we want to understand. So I won't go to the a priori one because it's not of interest for you, but for what I did, just so you know, so I just compare on different desiderata that general theory of interdisciplinarity tried to do, and I just compare the performance on a particular topic, and for what I look, at least it seems to satisfy a priori some of those desiderata. So we could say that we're minimally justified to go further, in the sense that it's not shitty enough that we don't have a priori reason to say like, bah, let's consider something else. So just keep that in mind. So just bear with me that maybe we have reason to go that way. I won't go through that because I think it's not that relevant for the rest that's coming. But if you want to do that particular work of saying like, okay, I have a theory or account or whatever you want to call it, and I want to do empirical work, you have a traduction process, if you want, an operationalization process that you have to do. So there's multiple ways to operationalize particular tool. One that you should look if you're interested, especially in digital humanities, it's Jean-Guy Meunier's work. So he theorized what form take theory in digital humanities. For just to spoil you out, it's a pragmatic account of scientific theory with different kind of model. Really nice work. So that's what I use, or I try to use to operationalize my approach. But we'll go super fast on that, just so I can show you some result. So just to be sure, yeah. So for the empirical or the a posteriori evaluation, there's two branches to that evaluation. So one is to say like, okay, we already have some theoretical way to try to understand cases of interdisciplinarity in science. We already have some tool, empirical tool that do that. So let's use those kind of tool on the same case study and then use the proposition to see how well it behaves in a certain sense, or at least does it grasp what we should expect to grasp from the more theoretically inclined approach or the more empirically inclined approach. So the general approach is what I call a contrastive analysis, so that's basically what I just told you. So I won't go into the too much. Oh, that's weird. That there's one constraint of interest just there. So if I want to do that contrastive approach, one problem that I have is that researchers know the problem with their tool. So people that use more theoretical inclined tool or those kind of approach, they do know that they need a little bit more of applicability in a certain sense. So they tend to transform with time what they do, what they used to do, to cover the limit that they already know that they tool have. So I cannot just use the last right theoretical analytic tool to analyze my case, because it's already tried to cover that problem that I mentioned. So I have to defend, I have to follow a particular constraint that say, okay, so if we want to keep the signal clear in a sense that we don't want the contrastive environment to be too much similar in a sense, we need to pick the more typical tool in each branch, just to help us to see more, to increase the science of the signal there of what my particular proposition is taking. So there's a big jump there that you have to accept, but keep in mind that's what I use to choose which tool I use afterward to analyze my particular case study. So let's jump to that case study as itself. So the case study, it's I thought I had an image there. Blah blah blah. Okay, so I did forget. So the case study, it's called the system biology. It's a really nice case. It's some people call it the successor of molecular biology. One thing that they tried to do that molecular biology wasn't super great to do is to implement those multi-level analysis, especially if you know a little bit of pharmacology or those biomedical body of work. Once you try to change something, there's always process that get in the way. So the idea is so let's build tools that help us to map how the different level of organization work and how they work together and interact together. So it's a really nice body of work. It was formulated around the 2000 by Kitano, that's a Japanese researcher, and he framed the project of that particular field of science as, so we'll build that multi-level analysis kind of tool and we'll use massively engineering tool to do so. So we'll just get as much data as we can. We standardize the way we collect data. So once we have that, we'll be able to do some large-scale analysis with using data produced from everywhere in the world. So pretty neat as a research, as a field of science. As a philosopher, it's nice in itself, but there's a instrumental reason also to go with that field. So it's a weird field for a weird case study for interdisciplinary research because it ends up creating a whole field of science. So usually it's pretty rare that interdisciplinary interaction end up in producing that much a big of epistemic unit, you could say. Usually it's highly specific, but that's one weird case for that. It's also easy to track if you want to do empirical work because system biology is, there's almost a trademark near it. So you track exactly the signal you want if you use a really scarce keyword. And and since it's pretty new in the sense that it's started in the 2000, we have, from the empirical side of view, we have access to all the data. If you work on a case study from the 17th century, then it's difficult to get all the data that you would want or all the research production about that particular subject of study. So there's epistemic reason to study that case, but also instrumental reason. So we'll skip the analysis that it's more theoretically inclined, just so I can show you a little bit of figure, because that's why you're there today. So data-wise, it's Web of Science data set, so I got access to it from the Observatoire des Sciences et Technologies that's based at UCAN, that really, they were really gentle in giving me access to their database, so they buy...
And it's a clean database.
It's not that clean. it's less dirty. It's less dirty. It's cleaner.
Less dirty.
But it's so it's really expensive to get access to bibliometric data. So they're really gentle in the sense that they ask for the fund, they buy data set from Web of Science each year, and they even include Scopus in that. Nature, it's a dimension database also. So they do a really nice work trying to bring all those data and put them accessible for researchers that try to do the work I try to do. But keep in mind, and that's why I'm mentioning that if you want to do bibliometric, there's a paywall. There's a strong paywall. There's some initiative that try to tackle that problem, but there's a big paywall for now, because if you want to have the best data set in a certain sense, you have to pay for that, and it's super expensive. So data source is that. To delineate my case study, I use, as I mentioned, system biology, so quite easy. Other case in the literature, you'll see it's super complicated. They go with keyword revised by specialists. Here, the signal is quite clear, so it's a nice case for that. And also, I took all the paper that have that system biology in the title, abstract keyword, and those basically that, and all the paper either citing or cited by that particular corpus. So the core data set that call it system biology, if you want. It's a 20,000 document, but the extended data set with all the documents citing and cited, it's around, it's quite big. So around 1 million there. So it increased super fast when you do those things. Keep in mind that's a super small case study for bibliometry. So let's look at some figure there. So that's how the document distribute in what I collected. As I mentioned before 2000, there's some mention, but really scarce. So you see really an increase after 2002. So Kitano book, I didn't show you that, but I think they were published around 2004, 2007. So super recent field. What you see in 2023 is simply that the database has a cutoff at a certain point. So that's where we don't have any data. So that's for the core corpus. For the extended one, cited or citing that particular corpus, we have documents cited that goes back to 1915, but most of them you see goes to in the 1980. So a lot more document. That's why you see all that the curve is all crossed that way. So that's for the general description. Let's look at the. I think I have 2 minutes. Do I have 7 other minutes, Charles?
You have 15 other minutes.
Ah, okay.
It's an
I
hour.
thought it was. Oh God. I was like running.
You're fine.
I thought I will never go to the figure.
And people go over time all the time.
Ah,
so
okay. So. Okay, so I'll go slower then.
breathe, man, breathe.
Yeah. So corpus description, as I mentioned, just a bunch of file, a bunch of document, but it doesn't say that much about how the field behave or at least interact with other fields of science. The tool that people tend to use, the standardized one, is called the Rao-Sterling index. So as I mentioned really fast earlier, the idea is to say like, so we take all the document in a particular field or a particular delineation that we find relevant. It could be author production, it could be institution production, and then we look at what they cite, and depending on what they cite classify to whatever discipline or subfield or field or whatever classification you can give to those particular paper. You assign a diversity metric, you assign a diversity score, and if it goes up, if it's near 1, then it's super interdisciplinary. If if it's around 0, it's not that much. Behind that particular tool, the minimal theory behind it doesn't go much further than what I will explain. So basically they say there's 3 dimensions to interdisciplinary diversity or interdisciplinary as diversity. So you have variety, so the kind of different discipline that you cite. Disparity or similarity, meaning like how close those fields that you cite are close from you. So if you're doing biology, bioengineering, and engineering, probably you will cite, the probability that you would cite in bioengineering biology work, it's higher than if you would cite for example, hard paper, or I don't have a good example, or theology paper, for example. So the idea is to keep that in mind, saying like, if you cite stuff that is different from you, but it's close to you, we should decrease your diversity score because it's way easier, it's way probable that you will cite those particular body of work. So it's to correct for that particular probability of citation. And also balance in the sense that if you cite once, you have 50 reference in your paper, 10% of it, like 5 paper is hard, theology, biology, physics, and whatever. Since they're not representing that much in your citation section, then we shouldn't score you higher because you cited 5 different disciplines super far away from you. We should normalize accordingly. So basic theory that behind those kind of tools, meaning diversity index to measure interdisciplinarity, is only that. That's why I mentioned before that it's not a lot of theoretical matter to clear out what cases should be considered as a counterexample or not, and how do you compare to. So the metric goes quite. It's not super complicated. The worst part, I would say, is it's not the calculus in itself. It's to get the probability of citation, because how do you get how probable from a biologist perspective I would cite psychology work. So the only way to get that particular measure or probability is to just look at all science and then look at how probable each discipline cite each other. So you have a super big matrix that is constructed on the whole body of work of science, and that's why we need Web of Science, because if not, we cannot compute that particular matrices that's needed for the calculus. So the calculus is quite simple, but the baseline data that you need to do so, super difficult to get. So that's why people are going for the other tool that I was mentioning before, network analysis, stuff like this, because there the dependency on that scale of data, and especially on big publisher, it's too strong as a constraint. Okay, so so what I did there for the result, and that's fresh of the oven as I mentioned, is to look, okay, so if we look at the core corpus and the extended one, let's look at what kind of discipline is we find in that. So I got 3 ways to operationalize discipline there. It's not all the discipline operationalization, but the first one is from the NSF, National Science Foundation from US. They have a really nice classification for science. I think it's not continued in a sense that we don't get new tag with year coming. I have to look a little bit on that, but their classification is high level of generality in a certain sense. So they try to classify what we usually call as a discipline. So biology, chemistry, those kind of super large epistemic unit, or institutional unit if you prefer. So I have that particular thing to operationalize it. A specialty also that come from NSF, we'll see that later. So it's smaller than a discipline, as you probably managed to infer. And also I use, they call it Web of Science subject category. So those are, think of it as keyword, but for journal. So it's one of the initial tools that people use to classify discipline affiliation for paper. There's a lot of problem with that. That's why people got to NSF. Now we're still trying to find nice metadata to classify field or discipline in science. But that's basically covered the whole easy metadata to get once you pass that paywall. Okay, so for system biology, as you say, a lot of biomedical. As I mentioned, it's as a successor of molecular biology, especially as a successor that want to solve complex problems that we find in biomedical and that need a lot of funding to have all the equipment to do so. It's not that surprising that we see a lot of biomedical work. But as you see, there's some change through time. Here, since we have different production per year, it's difficult to do comparison. So if we do a relative representation just there, you see that at least for biology it's quite stable. For here you see a lot of variation because there are less paper. So one surprising paper will influence more the distribution. But as you see, humanities seems to take a bigger part. It's a pretty weird thing trying to explain it, but what we should expect with that particular field of science, and that's a thing I did mention before, is that the role of mathematics and engineer should decrease, and we should see more biomedical. At least when you dig into literature, people that comment on what is system biology and what it's becoming, it's more on the applied way now and less on the more technical side of things because the machines do exist. So if we look at mathematics, for example, that just there, we see a decrease. It's proportionally, it's quite a big decrease, but it's not as big as we should expect. And for engineering, that's red just there. We see also what could be called a decrease, but not as big as the literature would say it normally. But keep in mind though, and that's an analysis that I need to do later. Since we look at the whole field, we don't look at the main paper of the field. So people, when you read a scientific article, usually you read the most important work, however you characterize it. So when you look at the top 5 paper in the field, or top 10 more cited paper of the field per year, you have a way more different profile there. But as a whole, the change are not as big as the literatures tend to defend.
Sorry, Kevin. The humanities, which color is? I cannot see very well.
Yeah, humanities aren't there.
Oh yeah, sorry. So I mix up colors. So it's professional field. Yeah.
Clinical medicine.
Professional here.
That's clinical medicine.
Yeah, you're right.
The
So
one that's
the other one
clinical
all.
medicine.
You're right. So even worse.
Even worse.
Because humanities and mathematics, they look very similar, but
Yeah, for engineering, mathematics.
Humanities isn't even visible.
Yeah, I messed those two up for the color.
Ah,
Anyway, so you see. But yeah, so for engineering and math, we don't see the decrease that we should expect. And for the biomedical, it didn't seem to increase that much. But since clinical medicine could be, yeah. There's work to do that, but it's always been a big part of system biology, at least taken as a whole. That's what we see here. If you look at the extended corpus, the idea behind it is to say like that will give us the background signal on how the field of system biology should work. Like if it doesn't have any particularity, it should behave like the general background in a sense. So it's just to give us a comparison to see, okay, so how one field behave in the general proximal environment where it lies. So again here, no relevant information. If we look there, so hard, we don't see it. But biology is still there. Biomedical research decreased a little bit, which is still, as I mentioned, surprising. That's chemistry just there. Surprising, it increased also a little bit, at least that's the background. So if the idea is to put the figure near each of those two figures near each other to see this difference. But as we saw in system biology, it seems at least to be stable and even increasing. Now we feel that the general trend goes in another way. So the idea eventually would be to try to maximize the signal by removing the noise behind it, but that's a thing that they didn't have the time to do. So yeah, so distribution of discipline. As the time go along, I think I won't go too much in those. So that's the what certain people could refer as field of science instead, or specialty instead of discipline. I won't go too much in that because I also have the subject category. I think it's more fine-grained, so the idea is to show you contrast also. So here, subject category, as I mentioned, those are qualification for journal that say like that's biochemistry, molecular biology, or whatever. It's way the granularity is oh God. The precision is a little bit higher, you can think it that way, because the journal could have multi-affiliation, because you can have a list of different subject category. But the thing is that the way that Web of Science attribute them to journal is unclear, so it's baseline to work in the field, but it's not clean data, I would say. So if we look at the subject area for the core corpus there, so again we have different kind of denomination for the field. Also, all that green there, it's the rest, in a sense that just pull out the top 10 subject area, because that's what we want to look at. That figure is a little bit better because I removed just to be sure. So there I removed the rest, if you want, just to again higher the signal a little bit, just to get more clarity about how the field behave. And here again we see some changes. It's more difficult to, as I mentioned, the literature don't tend to, they either go super specifically saying like, okay, omics method, which is difficult to grasp with those kind of tools, or engineering as a whole. So for example, you could say that those three kind of subject category could be as biomedical or something like that. So it's difficult to do comparison with what the literature say about the field, but we see again here some difference with time. For example, biochemistry and molecular biology. surprising that it go down, but maybe, and that's what the literature say, it seems to go a little bit up for the research method. So maybe the applied stuff is more mapped with the that particular way of characterizing, qualify if you want discipline. But again, it's something that I have to dig in later. Here again, that's for the extended corpus. So that's the whole signal in a sense. We see that, for example, biomedical research method seems to follow a similar trend. So when I will do the comparison to try to enhance the signal, probably it won't seem as important because compared to the background noise, the change seems to follow the same trend. So it's a thing again I'll have to do eventually. The last figure I wanted to show you, because they are just to show you color, it's when we apply the Raoult-Sterling index, what do we get what kind of result that we get? So here what you have, it's so for every year I pull every document of that particular year for the core and the extended corpus together, and then just measure the diversity metric there. So the point that you see is the value each year, and we can try to infer general trend. Here, as you see, there's a lot of variation for the core corpus. Probably there I would have to do some cleaning, meaning that remove those papers, saying like, okay, there's not enough paper, so they tend to influence too much the signal, so we don't get the general trend. But as you can see there, the background noise, really straight line like this. In science in general, you have to keep in mind that when you do those analysis on the whole scale of science, generally the trend goes up for every discipline. So that's not that surprising here that we see that the general environment where system biology lie seems to go up also. A thing that we see there is that it could be, there's some variation that goes on. Those would be nice to dig on, especially on the most cited paper, because then you will get a more fine-grained image about is 2000 to 2010 more interdisciplinary, meaning at the start of the field, do paper tend to cite more surprising stuff than later, especially since those citation probability change with time. But yeah, it's just to give you a small crux of what we can do. And based on that, if you look just at the point, it seems like the system biology is less interdisciplinary than it should, at least compared to the background. It could be that the background is way more interdisciplinary that was previously taught, but those measure at 0.3, you have to take into account that's pretty low in a certain sense. So you would say that the background is less interdisciplinary than the rest of science, at least if we compare it with different results already obtained with that. And system biology seems even lower. So again, the most cited paper analysis would be super important, just to extract more of that particular data set, and to see like, okay, so people maybe were just looking at the highly cited paper and not at the general trend of the field. So yeah, basically that's for, as I mentioned before, I want to test the proposition. I need to have typical reconstruction of the field. That's mostly the element that I mentioned before. And also I have to have an image of what empirically, what are the trend. And generally the idea in a couple of months would be to compare those particular images to see like, do we grasp something different that's either already present in the theoretical way of reconstructing how the field has behaved in the last 20 years, or does it at least follow up what we see with the bibliometric side of things? So I think I will stop there. So blah blah blah. The only thing that I wanted to show is that, oops, I don't see. So thesis is not done. That's the main point. I still have a lot of work to do, and yeah, thank you so much to participate in my lecture.
Quick 5-minute break as usual. So, if people have questions,
Or comment or whatever you want. I'm taking. Yes, Max.
At some point you said, thank you, also, very interesting. At some point you said, so yeah, I liked a lot how you, from other bibliometricians' talks, you spent the first half an hour to sort of argument why specific model, why specific tool, and I think that it shows that you're really trying to connect the philosophy of science with technical tools. And I think that's already something unique about your work. At some point you mentioned that you took systems biology because for you it's a weird case because it sort of shows that interdisciplinarity ended up being a unity, sort of a discipline, if I understood correctly. And that you said that, but I would have, as a historian, I would have expected the opposite. So perhaps I could revise my own assumptions, but I would expect that when there's like interdisciplinarity happening and sort of fields come together, they do form like united clusters, and then there's social processes of sort of cohesion, there's journals being formed, societies being formed, and so I want to ask you why you would expect the opposite. But then when I wrote that question, and then you showed the graph of the background where you did see this increase in diversity. So I guess that's what you were referring to in terms of like science overall is increasing in this diversity. So I don't know if you can comment on that idea of generally that we expect diversity to not close on itself but rather open up. And then more specifically, is there a possibility to track down fruitfulness empirically? Because it feels like those two things are somehow related, right? And then I have two more questions, but about because you were all the time comparing the signal with the background, right? And I was wondering, how do you interpret this notion of background? So it's not clear to me still what you mean by signal, by my nose. How do you interpret that in an actual discipline? So it's common language that we use when you use quantitative data, but how do you interpret those notions of background, of signal, of noise in terms of disciplines? Yeah.
Finish that. Great. Thank you so much for the. Oh God. So I'll try to answer all of those. Hopefully, I won't lose myself doing so. So yeah, for the first part, it was more a comment. So usually when I present stuff to sociologists of science, they tend to say, "Why do you explain us where you come from?" and all the first part in a certain sense that I didn't put as much work as I could. Or as I should, maybe on defining the kind of theoretical tool that you're working with. So that's not common. So it's nice that at least once I got a nice comment about that, because yeah, as you really well remarked, it's not that common in bibliometric, and that kind of work is it's marginal in the field. Yeah. So for the general trend for how interdisciplinary interaction, what they produce in science in general, it's a weird topic. Like from a philosophy of science perspective, we tend to focus on the we have no choice. Like we cannot read the whole literature, so people tend to focus on more not explosive but more remarkable cases. So that's why I think in our literature we tend to focus on discipline formation or new theory being born. From a theoretician of interdisciplinarity, though, it's quite clear that for them, most of the interdisciplinary interaction are way smaller than that, or produce smaller epistemic unit. That's why I use discipline. You could see it as a big epistemic unit, but usually for theorization of interdisciplinarity, there's smaller production there where tools from different disciplines are bring together to solve a particular problem, and then everyone goes back to their place and still do what they used to do. Even from philosopher of biology in general, there's a general trend of stopping to talk about theories or interfield theory, and then goes to only smaller scale interaction, and even like sometimes concept only. So I would say like in philosophy of science, true, there's a lot of example we have in mind that are more bigger epistemic unit that have been created by successful, whatever that means, interaction. But in when you look at that more fine-grained analysis, even theoretically we don't see those trends. In science in general, also with bibliometric tool, we don't see that. But you're right though that the dynamic that you mentioned before, like okay, we see interaction between some field of science. Eventually, they form their own journal, their own institution, if you want to call it that way, and then they get autonomous in a certain sense. We map that in bibliometric in a sense that you see that a field is highly interdisciplinary at start, and then become more autophagious in a certain sense, citing what they produce. So that's a signal that you see generally when you see field or discipline creation, but the most of the interaction would be smaller scale. That's why I mentioned it that way. And even some cases that are well studied in the philosophy of interdisciplinary literature, there's debate about okay, does that interaction has to be synchronic in a certain sense, because you have Grunianov that was there last week, at least for 2 case studies that he put forward. Super well documented case study. The interaction weren't synchronic, they were diachronic. So economic pick up the game theory from mathematics and then do stuff with it, and then share it to biology. Biology do stuff with it, and then biology share it back to economic. Economics say, yeah, that's great, but we can do better stuff with it. So those interactions are complex, and what is the general pattern or trend is not super clear, but at least one trend that I would say that is quite clear is that most of those interactions are smaller scale. Hopefully, so that's why I would say it's unusual cases, and because we don't see that much discipline creation. But it's a thing that people try to defend. Interdisciplinary research compared to monodisciplinary research. They say like, oh, it will help foster more discipline or more field. As is, it was something good. It could be something, I don't know. We have to measure it. But that way of thinking interdisciplinary relation tend to fade, I would say. So for the diversity signal, and it goes back to your to the other question about background noise. So if you only take a case of science, for example, environmental science in Spain, okay, from 1960 or whatever, I don't remember exactly your time period, but if you take that and you run those metrics like Raoult Sterling, or it could be true type ill diversity index, or DIV, or all the other stuff that people develop, you could see like a general trend going up for the diversity, but it's really important to map what is the background noise, because if science in general goes up also, maybe what you see as an increase, it's all actually a decrease if you compare it to the rest of science. And again, I go back to the problem with those metrics also in a certain sense. So we measure diversity in a way that we feel that satisfies some intuition that are super great. By the way, those minimal theory really efficient. They normalize for a lot of stuff that theorization of interdisciplinarity always put forward. But it's really important to have that contrast, at least because they are general trend in science, and especially since if you're a sociologist of science, something that you always tackle with, like as you observe your object, it tends to behave differently once you knew that it is observed. And also there's also program to support interdisciplinary research. So there's a lot of dynamic going on, so you need to be able to do this distinction between what is the signal of my particular phenomena of interest, could be your case study, for example, and what is going on in the rest of science. But also finding the right background noise, it's difficult because, I mean, the old science, it's a that map. It's a weird thing. Like, we know that it's biased for empirical data because we know it's mainly biomedical stuff. Natural science covering for social science is super bad for almost all of the field. But like for a field like philosophy, because it's highly diverse. Also, some field of philosophies are well documented and some other are not. So you have a lot of heterogeneity in the data quality. So if you pick the signal for natural science and say like, well, that's the background noise, you also in fault in a certain sense in trying to contrast what you're looking at. So that's why I use what people cite and who's citing that particular corpus to try to have that background noise. But to do a full-fledged analysis, I would need to have multiple ways to try to control for that background noise. So, and it's not only empirically that you have that problem. And again, I'm on that last question that you mentioned. Because even theoretically, you have to accommodate the fact that there's more and more program for interdisciplinary research, so the word will appear more, people will try to show their work or how their work is interdisciplinary, so you're stuck with a new problem also where people fake interdisciplinarity or do pseudo-integration in a sense to try to get grant, but also to give value to their research. So even only on the theoretical side, what people use to mention as interdisciplinary work or a typical way to do stuff, it's changing because it's a dynamic system. So it's a really complicated question. So hopefully you got half of a nice answer on that. Maybe for fruitfulness, you have first to try to operationalize it in a certain way. Even if you do theoretical work, like fruitfulness, it's in Kuhn's term, it's something that gets reused a lot. It's fruitful, but what does that mean? Is it fruitful, for example, the rest of society or only science? So innovation could be a marker of fruitfulness in a certain sense. You develop something that gets reused by engineering. Altmetric also try to map those kind of things. So sometimes you develop a particular concept, and then when we used to have access to Twitter data, we can use those things to say like, okay, that particular word or concept seems to have an effect or be used by people on social media in a certain way. So fruitfulness, it's difficult to track also. We have to frame it in a certain way, and then just to be sure that you measure what you try to measure, or at least that you know what you try to grasp in a sense. Some people have done it for internal work, so we talked about that with Charles. So David Chavalarias in France did really nice work tracking how concepts emerge in science, and they emerge from what. So which discipline bring what to the emergence of certain concept. So he has those things that he called philomemny. So it's a phylogenic, I would say, analogy to development of science, and then he tracked like novelty, apomorphy in biology, but no new concept that appear at some place, and to also try to track. Are they only convergence in the sense that they appear at the same time and there's no transfer from the different field that create or start to use that particular word? But yeah, that's one way that people have tried to work on and you could track the apparition of concept and their dissemination in the different field of science. If they fall off also, like they could be relevant for 10 years and then afterward people stop using them. And another field pick up that particular field. So there's work on that, but it's a really tricky question, I would say. Yeah. So I think I got all your questions. Did I miss something?
No, thank you. Sorry, I asked so many questions.
Yeah, that's it.
So I have questions about the empirical results, especially the metric,
Yeah.
the diversity index. Can you show the slide, please?
Yeah.
Because maybe I'm not getting it at all, but if you remove like this first, for example, the last one here. If you remove first 4 years, is there any change in anything? It looks like two non-changing metrics, and it's interesting that systems biology is not that different from background, but
Yeah.
and you also said that you expect that this diversity index is increasing everywhere, but is it actually very much increasing? I can't see the numbers, so I can't see how big is the
Yeah.
increase, for example, for background noise. Is it
But-
like 1% per 10 years? Or?
Yeah, so the general trend just there for the extended corpus is more, at least, reliable in a sense because we have way more document. That's what I mentioned with the system biology, so probably a nice cleaner work at the end, and we'll remove those kind of things. I will have to look at those just to be sure that it's really caused by the fact that there's not that many documents and it's not, but yeah, so that general trend is reliable in the sense that it increased, but you're right in the sense that it could increase less fast than the rest of science, so you're always stuck with that contrasting background. Yeah, and for system biology there, so I didn't put that figure because I'm still working on it and it's a whole thing. I have to rework it. But if you compare by percentile of citation, you see high difference and in the top 1% more cited paper, and that's super relevant because, and that's why. So ultimately, that with those data, otherwise than characterizing the field like, well, it's less or more interdisciplinary than backgrounds, it doesn't have value in itself, but the nice thing there is to contrast it to what people have said about the field, and what they have said seems to map more what we observe with top-cited paper as I mentioned before. So here, again, in absolute, those value, not super interesting because your case study, for example, could be in general less interdisciplinary, could be a smaller field or a bigger one, and some, because the way they construct, they tend to cite less, but they could cite more different document that they should in a sense, but those signals are always data set dependent in a sense. So the relevancy there is to see, okay, so people have said that system biology at start, engineering, mathematics, and then afterward omics method came in 2010, at least they were reconstructed as big contributor for the field, and then mathematics goes, all the mathematics biologists get pushed outside of the field, so those dynamics, we should expect to see some difference in the particular metric. But at least for the scale of the field, we don't see that particular signal, and also if the field, a way that index would be interesting in a sense, like if you say like, okay, we have a case study, which is the poster child of interdisciplinarity, it's always renew itself, it's always try to collaborate, do new stuff, then you can measure it how true it is. Does it change through time also? So for that particular case here, since I'm interested in how the relationship between the field build up the field of system biology. That's one information that I get. Once I get through those kind of things, the relative, for example, comparison where you could see like a metric that should have like how much that year differ from the so the background noise, and then how much differ the signal for system biology. That would be a thing to see, but also what those paper are citing in a certain sense, because paper are produced using that's a proxy using the element from other paper. And you could technically, if there's strong difference in how the field is structured, you would see difference in consumption through year. So I don't have the data there because, I did that yesterday. But those the kind of thing in the end that will be put forward to map a little bit more closely how the field changed through time, especially in its interaction with other field. I'm not sure if that answered your question, but I just wander around.
So in a sense, but I think my biggest problem was just like, what's the rate of these? Because maybe I just can't see the picture well, but I can't see that it's increasing at all. Or is it how big is this increase?
You mean for
last
the
picture? Yes. Like how many percent? What's the rate? Like it's 1.05, 1 point what?
Yeah, the absolute rate of increase, like it could be of interest, but in a sense, it's the general trend that you want to see. Because you mean maybe it's the color, but here, at least for the background noise,
Yes.
we see clearly that there's an increase.
Yes.
For that one, that increase probably it falls because of those outliers that tend to just skew the but the trend, at least from the eye there, would be a little bit lower than the background noise. So it could be parallel to the other one, but that's why I put those trends just to give a general idea. But your question more specifically is to say like, okay, I don't see increase because the color is bad.
No, not really. My question was like, what's the sense of talking of increase if it's that slow in a sense? Like, can we really say that this particular thing is becoming more interdisciplinary if its diversity index is 1% bigger? Is it
Technically, you could say it's not that much more interdisciplinary, but it would be. But that's the importance of the contrast there, because more compared to what? Like if the trend was the other way around, it would be super big, like if the other one just crashed. The background noise, for example, if it was going down to 1.0, you would say like, oh, it's super interdisciplinary because the general trend is to go down. But that's why the contrast that is not well shown there is really important too. But I mean, does it really better?
Like in the field, what kind of numbers people usually get? Because like, for example, in economics, if you say like,
Yeah.
my GDP is growing by 1%, it's a big and important result. But I don't know, if you test a drug and say, it's 1% more effective, it's not a result at all.
Yeah. So for the effect, how could I answer that? It's not that important, I would say, the scale, unless contrastively. I think, and at least bibliometric will defend you can try to do comparative comparison, saying like that field is way better or it's way more interdisciplinary than the other one. But for me, those are really weird comparison, because the real contrast is what is going on in the background. And even as I mentioned, for the general trend in science, if it goes up, still you're not working with the same data set. So usually people don't compare data set with other data set. Projection or result from one data set to another one. Some people try to do that, mapping the whole science to give, okay, that's the general trend that everyone can compare, but in bibliometric it's not well seen to do those kind of things.
Mm-hmm.
So that's why usually you redo all the measure based on your data set. Even, for example, if 2 years ago someone did the same thing and measure, for example, the proportion of women in the field or production, the proportion of women in the higher cited paper in the field, it's difficult to do that, especially if you think about Web of Science. They don't just add new data for each year where there's new production. They also add paper from the other year. They just extend their covering to stuff that weren't included before. So next year, if I'll do the exact, if I do the exact same analysis there, for example, at the just there for the number of paper, we'll eventually go there. So maybe I won't get the same result because the data set would also add new paper in those particular years. So it's difficult to do analysis in absolute for those particular analysis. I have to be careful of that, but I see your point in the sense that point one, is it relevant or not? It depends on your research question, I would say, what you try to show. Yeah.
Thank you for the talk. I have a quick question. When you answered to Max, you talked about faking interdisciplinarity. How do you fake interdisciplinarity?
Well, dear, so you know which kind of metric people use to measure interdisciplinarity. So one way to fake it is to just try to rig the system by doing what the tool is doing. So that's typical problem when you do sociology. If the person being observed know how you try to measure them or measure a particular behavior, they could try to optimize the way they behave to score higher on those kind of things. So it's a general thing. So if Peter mentioned Peter, right? Yeah, I think you might mention earlier Google or something like this. There's company that you can hire just to help you your company to always get higher result or being higher class on the Google search stuff. So optimization is quite a problem in multiple fields. In science, especially in system where people are using a lot of those metrics to evaluate the researcher or attribute funds. So I think it's not that bad here for the FNRS, but still I heard some concerning stuff for funding for chargé de recherche. Mais UK is the worst example for that, using a lot of bibliometric measure to evaluate research production and quality, and people play with those things. Maybe a way also to answer your question or to give another example for that. So one of my past jobs was to try to optimize the result of our university on international certification for sustainability development. So we knew the kind of tool they were measuring, and we were testing, okay, we should put work in that because we'll get more increase in points. So people, once you know the tool, yeah. So you can fake. So people, some person, for example, will try to fake a profile of I'm an interdisciplinarian. I work with a lot of different researcher. That's not from the metric kind of stuff. You can try to fake it in your funding application. You could say like there's a high probability of really impactful result for society. That's something that people tend to do also. But yeah, faking that. You could try to do that for your paper, for example. If you want your production to score higher on that, you already know that I have to balance the source that I use. I have to cite stuff that are really far away or lower probability of me citing those kind of things. And I have also to, what's the other one? Yeah, the proportion should be even. So you know how to trick the system if it was relevant for you in that. So there's way to trick the metric system once you know which kind of tools are there, but there's some cases where people try to put forward that they do interdisciplinary work and it's not the case. To be more, to go less on the conspiration side of things, actually for now, depending on your research system, it's not that paying to try to fake that, in a sense that the success rate for interdisciplinary work is lesser usually on funding application. There's work, I think it's on the Norwegian system about that showed that typically your funding application have way worse rate of success. And also in research, like in economics specifically, because I have colleagues working on that, and especially on that topic, the structure of the field is based on, you have those top journal. If you publish in that, you're a real economist. If you publish in everything else, you're a bad economist. So that's how you construct your thing. But if you look at those top 5 paper, their diversity metric is super low. If you compare it to, for example, the rest of the field of the other paper produced in the field of economics. So there, if your entry as a professor is evaluated by other colleagues in economics, and the way they evaluate your candidacy or profile is based on have you published and those kind of things, it's a really bad strategy to try to do interdisciplinary work. It's not a good strategy, I would say. Yeah, hopefully, so I turn around your question a little bit. So faking, you have multiple way to do it, but for now, I think it's not that a good payoff. So don't do it. Yeah. Yeah, Charles.
Well, I just wasn't sure quite what when you got to the end, I wasn't quite exactly sure what the argument was. So do you take it that Rouse Sterling is capturing the kind of interdisciplinarity that you care about, and the systems bio people are wrong in their self-understanding? Or do you think the systems bio people are right and Rouse Sterling is missing?
Yeah.
Or are they both right and they're just using different meanings of interdisciplinarity, which I guess is always an answer, right? I mean, you could just have the pluralist response if you wanted, but...
Yeah. Well, it's always a difficult. The usual way to critique how philosophers do work, and they highly criticize on that. You have to know that if you're a philosopher and you work with people doing empirical work, is that we cherry pick the cases that work for us, and we cherry pick only on the visible part of science. In a sense that we read science or nature, but we don't read the rest of the production. And it's, in a certain sense, a bad thing. So I have a colleague of mine in a book, I won't name the person, but mention, if you know scientific literature, you'll know what's wrong with that thing. But they say like, yeah, it's weird in science, scientists tend to hide their methodology because they put it at the end of their paper. Is that something, does that seem strange to you?
Well, the claim or?
So the claim that the person mentioned is that a proof that, I will stronger it a little bit, so the scientists don't care about methodology, and the proof of that is that the methodology section is always at the end of the article. Is that something seems odd with that particular description that I just...
On the journal. I mean, for a few journals it's at the end. For some journals it's in the supplementary material. For some journals it's in the middle.
So in science and nature, yes, they have multiple journals, but technically you have methodology at the end. Not the rest of science. The IMRAD structure, introductory, methodology, result, analysis, and development, is baseline structure of article in the majority of science, at least natural science, but even wider than that because people tend to emulate practices from natural science. So the fact that a colleague would say like, yeah, scientists put their methodology at the end, it's a proof that they never read a real research article. They only read the top production of the science as if it was not extraordinary claim, or if you read the Nature and Science objective, I don't know how to say it in English, but every journal have a certain thing that they try to do, and for Science and Nature they try to publish extraordinary stuff. They don't publish like what is the most well supported or what is the ground truth. It's extraordinary, so you read only the visible part of science when you read only those articles. So to go back to the to your point, so there's one problem I think that philosophers tend to have, to read only the visible part of science, but in a certain sense they're not that far from it's not a bad strategy to defend them, because scientists also cite only the top part of science. So what influence what they do is what the top side, the major work published in a highly cited journal or produced. So if you want to get the gist of a field and what people bring when they do their research, if they only cite and read highly already cited work, you're not wrong in assuming that that's the background, the epistemic background in which they work. So if the fact that they don't cite that some paper are never cited, in bibliometrics you have the possibility to look at those particular paper, what they look like, how they constructed, but you're not wrong in assuming that as an heuristic to read only the visible part of science, because that's where the information that scientists use is present. So that's one thing. So to come back to your question, Charles. So when I don't want to say that one is missing something or the other one is great or bad. That's the whole argument I try to put forward there. So I think there's bad example, but there's good reason why philosopher reads certain kind of article and not other one. And I think they get a good image of certain field of interest when they do so. So the idea is less to contrast those two things, saying like one that approach is good, the other one is bad. It's just that they grasp something different. And the back and forth I was doing with the, I should look at the top-sided papers to reconstruct, at least find that signal that some philosopher of science that work on system biology found. because probably what they found was exactly how the field was behaving, but how the field is behaving could be only reported in top-cited journal or top-cited paper.
Mm-hmm.
So to come back to the role of that particular comparison is just to say like, okay, if I do more theoretical constraint work, we reconstruct the field that way. So I didn't present it to you, but O'Malley, Maureen O'Malley did work a lot on those kind of things. Orkun Sawyer, Boogerd also. There's a lot of literature on that particular field of science. And the idea with the other one is to say, okay, but empirically, what do we see? And to evaluate the proposition that I briefly mentioned before is to say, like, do we grasp at least some part of what the other one grasped? Because if we have a totally different picture of the field of science and we cannot explain by, for example, the number of paper you can read as a philosopher, or in bibliometric by the fact that the signal between the less cited paper and the more cited is different, then probably the tool is shitty. That's the big point behind.
Sure.
To get that
Cool.
separation.
Keep going. Keep going. You got 10 minutes. Keep going.
Two questions. One is more out of curiosity. The other one is also. But the first one is, you mentioned that there are stable alternatives to all this Web of Science because it's very expensive, and sort of all these big publishers are going into being data brokers rather than publishers. And so, what are those alternatives? And the other question is that it feels to me that a lot of like bibliometric work depends on having healthy metadata, right?
Mm-hmm.
So what happens when the NSF produces bad data because they are underfunded, which is a very possible historical possibility, and so yeah. What happens when it feels like you always need some sort of outside view, an outside characterization? You already mentioned it. The social sciences are not well archived. They are not well researched. So of course the metadata is going to be more poor. So I'm just wondering about the implications of continuing to do a lot of bibliometric work on data that is already available. How do we resist that bias towards doing more work on natural sciences and also whether the social sciences, and just overall this need for this outside perspective that creates healthy metadata.
Small question again. God. And so maybe for the alternative one that it's really put forward now, it's called OpenAlex. So you can have access to their full code and do stuff with that. It's not a really interesting thing because you have to host your own data and do the collection and everything, but they have a database where they collect whatever they can. The comparison for now is encouraging in the sense that OpenAlex was way shitter before. Now it's not on par with Scopus, which is a little bit less good than Web of Science, but it getting there. And there's a lot of researcher also, because in bibliometrics, especially with their use and the abuse of the tool that they produce, they tend to be highly militant in the sense they try to do better science and just be sure that their metric are not used to constraint researcher or measure whatever people try to measure with, those kind of things. So they try to be highly careful, but also to build or push for alternatives. So OpenAlex is well supported by a lot of bibliometricians. The thing is always that if you want to publish in Nature or in Science, and it's always the symbolic capital problem, if you want to have a good career, you have to publish in a highly ranked journal. To do so, you have to get the better data or the best tool for that. So if you use OpenAlex because you say that that's the future, if we rely too much on Web of Science, Scopus, Dimension, then we're stuck with the data behind the paywall. And if they decide tomorrow that they change everything, they increase the paywall, or same thing that happened with Twitter in a sense, like they just choose, we cut the access to researcher, and then all people that were doing stuff with that now have to pay us to do what they used to do. But yeah, so people are pushing for OpenAlex specifically. Dimension also, it's another database that I have to mention. It's linked with the Nature published group. I don't remember exactly their name. Just give me a moment because I don't want to Dimension. So it's still data behind the paywall. There's access. Some access to it, but they're really open to what bibliometricians are saying. So, for example, in our meeting group for bibliometry, we talk with them with the project that they have. They were hearing our complaint about where science data was going. So they're quite open on that. So it's another alternative, at least that some people have pushed because they seems to be more open. We'll see also how Scopus and Web of Science will behave, because with all the pressure, and it goes to the other question that you have, with all the pressure to get more open access article, and especially with funding agency that now put that as an obligation for researcher getting funded by those agency, they tend to adapt. So sometimes not in the right way, but yeah, there's not that many options to your question. For now, OpenAlex is a good thing. OpenAlex, like Alex,
OpenAlex, like the person.
Yeah, I will send you the thing afterward. Yeah, just to come back to your question to finish eventually. But the thing is that the problem with that database is not well known. So for Web of Science and for Scopus and Dimension, we know some of the problems. So for example, the affiliation for author is not super clear, or where you mention which who found you, it's not always well documented. So we know the problem with the different data set. So for OpenAlex, it's changing a lot and it's not well characterized. So if you go that way to do some of that work, yes, it's nice because you already have ready-made tool to do stuff with that, because since it's open, people try to create the environment, the ecosystem for it to work. But the problem with it, it's not super clear which kind of part of science it doesn't map well, and so there's some hiccup or problem that you will face with that. And yeah, for the bias that you mentioned for natural science, I mean, it's difficult to. So you sometimes you have alternative data set that you can use that cover more what you have in mind. So that's one way to look. It's rarely they're not behind paywall. The thing is that one thing that make the signal for natural science so strong is that there were a lot of effort from USA partially to put forward like open data. So for example, NIH, that National Institute, anyway, biomedical research, they have really strong policy for open access and that people have access to data. So for example, if you publish a paper and you don't render it accessible a couple months afterward, you cannot you lose your grant, and you lose the possibility to apply to the grant. So we try in Canada the strategy to say like, well, it would be nice if you render your paper open access afterward. It didn't work. So strong stance as they did work. That's why we have a stronger signal for biomedical and natural science. There's also some journal that managed by some society that did push for those particular agenda, like having the research mostly accessible, but for SHS, it's difficult to see how do we get more covering. One problem is book; it's not well documented, and And that's a big part. In economics, it's a big thing. In most of the field, it's not a nice thing to have a book, but it's not the case in philosophy, for example, or in plethora of social science. So the gap will still be there for a couple of years, that's for sure. And the community have to just build those, create the tool to render those things accessible. So for now, we're so stuck there because we don't have funding. If you compare natural science for social science, in Canada, it's 1/3 of the funding that goes for social science, but it's 50% of the researcher. So the competition is super high. So everyone is fighting to publish where they could, so they don't care about doing, we'll publish in that journal because it's open access instead of another one, or just say something about that publisher that want me to pay fees to render my article, to publish my article. So yeah, how do we resist that thing? It's people have to do stuff, but since we're not that well funded, we don't have the same mean or the same capacity in a sense to just hold our stance. So, and for the metadata reliance, maybe one point on that. That's why I was mentioning those bottom-up approach to try to measure interdisciplinarity, but it goes for every metric you can imagine, because for the metadata for citation is super hard to get, because you have to get the metadata for a paper is not that bad. It's quite easy to get in a sense that it's well documented in open database. But the thing is always the citation mentioned, because you have to have the whole data of science to index every citation reference in your reference section to know where it was published, what are the metadata of the paper that you mentioned. So that's the big problem. That's why people tend to try to go away from citation network, but it do so much work that we're quite stuck for now. So without a reliable way to get the citation network for paper, we lose almost all of our tool, at least in bibliometric, because you lose which paper is more visible in a sense or have higher impact. You lose also what people use to produce that paper. You lose the inference about collaboration that are not co-cited papers. So if you co-cite a paper, if we write a paper together, maybe we collaborate, probably, but citation network are used to map epistemic community also, or just social community. So that's the biggest problem, at least on my point of view, from naive point of view. Hopefully.
It's time. So let's thank our speaker.
Thank you so much.